Hello and welcome everyone to this webinar. My name is Gregor Završnik and I am a geospatial consultant specializing in geospatial data preservation. And today I would like to introduce you to the field of preservation of digital geospatial records. And according to the list of attendees and of the listeners, you're coming from a lot of different fields. That is why we will cover the basics first to get everyone up to speed and then go to the crucial stuff. That is why we are starting with the introduction to geospatial data itself and its role in organizations in order to understand why it's important to preserve it for the long term. So when do you actually need geodata? You need them anytime you want to repair your utilities or roads, because especially in this time of the epidemic, the roads are mostly empty. So at least in our country, they started to repair a lot of roads. And in order to plan your activities in maintenance of infrastructure, you need to know where it is. If you want to buy or sell a house, you also need to know where the house is located, because as you know, location is the importance when you're selling real estate. So in order to estimate the cost of your house, to estimate the benefits of having close schools or hospitals is also important. So the location is important when you're buying or selling a house. If we go broader and if we say that if you want to plan your policies, environmental policies, economic policies, or even educational policies, you need to know where the impacts are taking place and what other factors are there to influence those policies. And also, if you want to measure the policies, the effects of it, you need to know where to measure it from. And if you have statistical data, you need to put it to a certain area. Now, if you talk about food production in agriculture, we also need to have geodata to locate the best soils, to locate the climate situation, and also for the farmers to plan their own crops and where to use which type of fertilizer. And in logistics, the transportation is heavily reliant on location and navigation tools that also help us. And using geospatial data helps us analyze logistics and plan it for the future. And if we go even bigger, if you want to plan for the future, you need to know the information from the past. You need to know where your buildings are, what was happening if we implemented some plans in the past, how they impacted. If you want to do spatial planning, you need to have old maps to analyze the progression and the impacts of the progression on the future. So basically, we see that 80% of all data is related to a location. So if you want to store information about the past, storing geodata is a logical next step. So when do we need the old archival geodata? When do we need the previous records that are not currently valid anymore, but show us the time before that? It's mostly in land disputes. If you want to know where your parcel or building or piece of land was and who owned it and what was the size of it, you need to have good records from the past. And this is important not just on the personal or business level, but in many cases also it shows us how to solve problems between nations, between states, because you have tax information based on land records. Now, if you want to manage and protect your underground infrastructure, you also need to have very good geodata about where your infrastructure lies. So in order to find that, we need to archive those data properly and also make it available so that we can reuse it and protect our infrastructure. Now to a more unusual use of geodata. Usually in business systems, we have tools like business intelligence or BI, which also use statistical data to predict trends for the future based on the data from the past. However, those trends are usually recorded in statistical regions that also change boundaries through time. So this is where all geodata can help us predict future sales, for instance, or future trends in a proper manner, because maybe the data from the tables are addressing a certain area that was changed or merged with a different area or split apart. So if we don't have the old geodata of boundaries, we cannot compare and plan for the future in the long run. Then if you want to establish environmental impacts of some past decisions and to predict what a similar decision in the future would mean for the environment, you also need to have very good land records and biodiversity records in order to see what impact some works or projects in nature had to the surrounding areas. Now, if we go to a more complex solution, we can also use multivariate economic impacts analysis using geodata. And this is where we would use an AI system combining multiple sources of multiple impacts to see how, for instance, new technologies influence a development of economical factors. I recently worked on a study where they were analyzing how fiber optic cables in the rural areas helped to develop economy over there. And last but not least, we also need to analyze the agricultural production past based on multivariant impact factors. And this is where we also need the geodata that shows us location of crops, types of soils, and so on. And that's what I wanted to show in this slide, that there are different areas on different types of data, but geodata is always somewhere around there. So if we boil down the fact that the world's most valuable resource is not oil anymore, but data, then we can say that we are slowly moving towards a data-driven economy, where the archives, the libraries, the museums, the huge databases of data that is being recorded is going to become the gold mines of the economy of the future. If you want to offer this data to the businesses, we need to do it in the most available way, meaning fast, interoperable, and standardized. So how do the organizations use geodata today? Most organizations use web-based geo apps like Google Maps, Bing Maps, and so on. We have a lot of national portals and international portals serving web services using geodata in the archival world, in the environmental world, and so on. Some organizations that have more specialized knowledge and requirements, they use proprietary GIS systems that can be open source, or they can also be very specialized, but they still use geodata. And those data are usually in very specialized formats, but if there are some common GIS tools, then they can also use standardized formats. Then we also use geodata in business intelligence systems, as I already mentioned before. And of course, more and more geodata is being used in the AI applications with machine learning and deep learning, where they analyze a huge amount of data to predict trends for the future. So in order to make a case for long-term preservation of geodata, Let me show you the example of how time series of geodata was used with AI in order to predict future danger of traffic accidents and to plan actions to avoid them. This is an example from an ESRI conference 2 years ago. ESRI is a GIS solution provider. So the benefits of an AI or machine learning applications are that it can identify patterns from huge amount of data, which could possibly be too difficult or even impossible to analyze manually. And we need a lot of data to train the machine to give it useful information so that it gives us useful predictions. So in this case, they analyzed more than 10 correlated parameters like temperature, wind speed, snow depth, day of the week, time of day, month, road width, road alignment, and so on. All geolocated in space across 7 years, which included more than 500,000 segments of streets, and it's also included about 400,000 events of accidents. So this is a risk assessment map of where potential traffic accidents are likely to happen and where the authorities should focus their efforts to actually avoid them. We can safely conclude that this is the future of decision-making process, learning from the past for the better decisions of the future using AI and deep learning approaches. Now let's take a look at what geospatial digital records look like. They basically describe where something is located in space using some type of coordinate reference system. Spatial description of where something is located in space can also be a vague description like name of the place, street address, or like something as vague as at the crossing of First and Block Street. However, in the case of geodata, we use geographic coordinate systems using measurement coordinates like the green example down in the right. The next question we often get is, what is the difference between spatial and geospatial data? So spatial data pertains mainly to space, to the shape, describing shape and size of objects and structures like 3D objects and structures like beam systems, so building information systems, and other entities in space with a smaller size. On the other hand, geodata is actually pertaining to geography, so to larger structures, areas, and land masses where you actually need a geographical coordinate system to describe it. So in case of geodata specifications for archiving, we are addressing the second part of objects, although I think that the spatial data objects like 3D models and BIM systems should also get their own specifications, but this is not currently being done, but I guess it will be in the future. So basically, if we go to the geographic data, to explain it a little bit further, we will take a look at how we represent the real world, with what kind of objects or records we do that. So if we take that this is a building in the real world, we can describe it with a shape constructed by vectors, which are made from coordinate pairs. So we simplify it by describing it as a vector. So these are called the vector geodata. And on the other hand, we can also create a raster image, a grid that actually has values in their cells covering a certain area and thereby describing the object. Why am I explaining this? Because these two types of objects or formats for geodata demand different approaches for storage, for further preservation. So let's see how geodata is constructed in the case of vector data. We usually have the graphic representation, which can be a point, a line, or a polygon describing an object in space. And then we have a tabular information added to it. It can be added through a database, through a application-based list of entities and so on. But basically, this is where the combination of graphics and databases come together. And in order to actually know what this database and map are all about, we also add metadata, which usually come in machine-readable form. It's best if they are standardized so that they can be reused for searching for this data. And this structure is actually very important because this is where you see that you can combine maps, so geodata, with different types of tables of databases, and this is what can give us very good results and display the patterns in the map. Now, when we have a lot of these layers of data, be it vector or raster based, we can combine them together, and one on top of each other, they give us the whole picture, a good model of the landscape we're trying to analyze. And this is where we can then use different tools to find correlations between events, between patterns, and also gather information about the proximity of objects to other elements and so on. So where do we get geodata? The source of geodata is usually field surveys, where we go with measuring instruments like GPS or surveying equipment to measure data and create maps out of it. Then for large areas, it's better to use aerial and satellite imagery and LiDAR nowadays, which gives us a good 3D model of the location. Then if we have some old maps and we don't have the access to the old field surveys or old aerial imagery, we can usually just scan and digitize the results, like the maps that can be digitized and create vector data or raster data in order to use them in GIS systems. And of course, nowadays, the new way of acquiring geodata is by the sensors we use every day, like GPS in our phone, GPS in our car, combination of telemetry data and so on. And this data can be used because it can in AI machines, in AI applications, especially because we can gather large amounts of data in real time. And in this slide, you can see a heat map where we can see how dense the population was in a certain part of town. You can see that this can be used then to track the masses of people on car lots, on store parkings, or even in epidemic use cases like we have now with the COVID-19 epidemic. Now let's summarize why long-term preservation of geodata is useful. We can all agree that the geodata from the past is the fuel for the location intelligence of the future, and to achieve this, we need to preserve data in standardized formats to make machine-readable access easily available through interoperable APIs. With comprehensive descriptions in form of metadata, which comes very, very handy when businesses, governments, and citizens want to find useful information in form of geodata. And this is what the EU Open Data Directive is all about, because making public data available contributes to a more competitive economic environment. This is because if the businesses have a faster access to data in the data-driven economy, this brings a competitive advantage for existing and emerging businesses and helps to encourage innovative startups to find new solutions for what we until now thought were impossible tasks or impossible questions. Just look at what happened with the arrival of high-speed internet. How many new services were introduced? How our lives changed? This is also how the availability of geodata could help us change our lives, just like we changed our lives when Google Maps became available. So in order to fulfill this need, we developed the specifications in the eArch project, now being developed under the eArchiving building block. So the geodata content type specifications are a part of an overall eArchiving specifications package developed within eArch project. So if you're not familiar with it, let me just quickly introduce them to you. We have the common specifications for information packages, and then the eArch CIP, AIP, and DIP types, so that the information could be accessible in an interoperable way across organizations, across nation states in Europe. Because this will help us to increase the speed by which we exchange data and increase the accessibility to drive the data-driven economy. And this would also help us get more results in a shorter time. So the main idea was to have a common information package structure for all organizations to ease moving them around. However, we know that there are already a lot of solutions that have their own structures, so we can still use the content information type specifications, such as the GeoCITS in our case, which are solution agnostic and actually describe what type of data and how needs to be contained within the package in order to ensure long-term preservation. So you can get the latest data specification on this link that you see below on the left. And we are already on the next slide, where we can see that we currently have available specifications for geodata preservation. However, in the course of the eArch 3 project within the eArchiving building block, we are developing specifications for GIS systems preservation, because we believe that we should store basic parameters on how to create a GIS system, not store the systems themselves. And of course, the implementation guidelines on how to implement these two types of specifications. Now, in the bottom left, you see the link to the GeoCITS specification, the latest version, and be advised that the letter sizes in GeoCITS matter. So G and CITS need to be large caps. Okay, so to explain the structure of content of these specifications, let me first say what the general idea is. We want to preserve the way and the content needed to produce an information product. So every map, every parcel map or map of the current building area on anything that is produced in an official way is an information product. In order to have the information product, we need to have the data, which come in the forms of vector data, raster data, databases, lists, code pages, and models. And then the GIS tools that we used and how we use them in order to produce that information product. And these are the two types of specifications that we are currently maintaining and developing. As I mentioned, the data is already developed, and the GIS tools preservation is being developed now. And in GIS tools, we want to preserve how data was organized in a project or organized within the application to achieve the results, what kind of queries were used, what kind of cartographic projections were used, what kind of transformations were used in order to create the end product, and of course, what type of symbology was used to display it, which geoprocessing tasks were used, which exports were created to create the information products like heat maps or logistic routes or even lists. So even ordinary lists are usually a result of a map. So basically, to get the picture on the screen, we need to store the data and GIS tools in order to have it. Now, this is an example of a very complex procedure that is used within GIS to get a result, to get, for instance, let's say a calculation of land tax can be creation from combination of multiple data sets. And in order to document how these data sets were combined and which formulas were used for which attributes, we need to store the geoprocessing workflows and queries that were used. Then, if we combine this to an even greater level, we see that often information packages or information products are created from multiple GIS systems. And in order to preserve the possibility of creation of such an information project, this is, for instance, an example of a building permit, that in order to create it, you need to access GIS systems in the Environmental Agency, Defense Agency, Ministry of Culture, Ministry of Agriculture, Ministry of Environment, and so on. So the specifications also intend to define how to maintain the systems in order to be able to reconstruct the actual state of data at a certain time and date in the past. Because if we can't do that, we cannot recreate the building permit. That could be a matter of some legal disputes between companies, government, and so on. And the whole idea of geodata preservation is to help governments, organizations, and citizens to protect their legal safety, and this is one of the ways to do it. So, in order to explain the idea of specifications for geodata, I want to tell you a story. This is a picture of an old phone that a colleague of mine, who is an electrotechnician and has a hobby of restoring old gadgets, found. It's an Iskra phone from the 80s. It got a lot of rewards for its design, and it was very popular at the time. However, it's not working. It wasn't working, and he wanted to correct or repair anything that was wrong with it. So what happened? He opened it up, but first he turned it back, turned it around, and on the bottom there was a label which described everything about the package, so about the phone. It described the company that produced it, the serial number, the rewards it got, and actually this is what metadata is supposed to describe about the geo package. Then when he opened it, he saw there was a lot of parts, some circuit boards, speakers, some switches, and so on, but he still needed to know exactly how they were connected. So I guess that people at Iskra were very smart, and actually they included the schemas and the documentation about how to use this within the phone. So this is what we want to do with the geo package. We want to include the schemas and documentation on how to use this within the package. And this is how the schemas look like. So my colleague was then able to find, maybe replicate some things, some circuits, to rebuild an old phone. So this is an example of an information package that we created for a basic shapefile of boundaries of a country, for instance. And we would really like to invite you to go to this link on the upper right corner, go to our GitHub, download the specifications, and please give us feedback, because we are creating this for you. If you think that there's something missing, if you think that we should address some other issues that we're not addressing, if you would like to recommend us change something or add something, please don't hesitate to put some comments on our GitHub page, post an issue, and we will address it for you. So to go back to the structure of the package, we have three basic folders. One is the data, or geodata in our case. The second one is documentation, and the third one is the metadata. So within the geodata, we first store the data in the middle, the original representation, where we store the original data that is from the system. Then we also recommend that this data is to be converted to a GML representation in case of vector data or any other long-term preservation format that is recommended for geodata. And of course, technical documentation that needs to be with the data so that we can understand and use it, like the attribute definitions, visualizations, and so on. We also have the documentation folder within which we have the context documentation, the project reports or interviews with the users, with the people who maintain the data, information about the legal background, information about how it was used in other examples that are not so obvious. And of course, the third folder should contain the metadata of the geodata that was stored. Now, I will not go into greater detail about this information package on this slide because you can see our already existing lectures on e-archiving specifications that we had on our Geospatial preservation conference last year, and the long-term preservation formats that can be found on the links on the slide. So let us conclude this part by talking about the benefits of using Geodata's CITS specifications. First of all, we based our recommendations on how to preserve geospatial data on community standards from OGC and ISO standards for GML, for metadata, for other elements as well. We recommended long-term preservation formats like GML 3.2.1 and TIFF for rasters, and the metadata in the ISO 19115 or 119 so that it can be used in the future by human or machine users. So that's why they need to be in a machine readable formats as well. The specifications also provide examples for different types of packages based on different data types. Like we have examples for rasters, examples for vectors. However, if you have any questions about any specific organizations, please ask us and we will research your question. All in all, we think that these specifications are applicable to most archival solutions because they are solution agnostic and they mainly list the elements that need to be within the package. Now, we saw what solutions we offer to the organizations we want to serve. Now we need to know how to implement these specifications in these types of organizations. So this is what the guidelines will actually include, some strategies for implementing an accessible archive. And why do I say accessible? Because most of the archives today are not organized for fast information access. But if you are to serve the data-driven economy, we need to make it machine-readable and accessible through service-oriented architecture. We are, of course, talking about the data that has no access restrictions. The data with access restrictions could still be only accessed locally in the archive or via secure access protocols by those with access permissions. So in order to design the strategies, we first looked at what are the main challenges for the users of this specification. And based on our experiences from the Slovenian National Archives, the Danish National Archives, and several mapping agencies, and some solution providers, we learned that the geodata producers lack the preservation expertise. This was shown to us by the destruction of certain data because when the backups were created, they were put on CDs or magnetic tapes, and they were put in the closet and never thought of it again. However, we know that CDs and magnetic tapes, they're not forever, so we need to maintain them. Maybe we need to rewind tapes every now and then. We need to copy the CD-ROMs and so on. So it's generally known that people usually don't have the preservation expertise. So this is where we need to connect them to the archives. Then The archiving costs a lot of money, and the geodata producers don't have a lot of money to think about the archiving. This costs additional work for their staff, so we need to devise strategies that change the workflows in a way that minimizes the effort needed to preserve geodata and creates a good package for us. We also need to discuss why we need old geodata, and as I mentioned today, there are a lot of use cases that need to come out to be presented to geodata producers. And of course, the main question always is what formats we should use for long-term preservation. And this can be done by looking at the specifications, or you can also check the YouTube video that I mentioned before. Then we have the digital archives, where a normal historian, which is a general type of employee in the archives, does not understand complex digital systems. So they would need to employ people who have this knowledge or educate their own historians on the field of geospatial data. Then the second thing is they still think that they need to acquisition the data after 30 years, but this is a period that is too long for digital data. I mean, can you imagine how would you use the word processor files from 30 years ago, from the 1990s? How would you use the spreadsheets from Lotus 123 or something like that? It's impossible. Then the data producers treat the archiving as a burden, so they usually don't want to communicate or are not so enthusiastic about it as the digital archives are, or the archives in general. And the archives don't have the geo experts needed to talk to them, so we need to connect them. They also want to know what formats we should use, and this is a general discussion across the board, across all users. Then we have the solution providers, who generally want to know how will this change impact their solution. How will they need to change the data model they have, how they need to reorganize their workflows and so on, and how much it will cost, because in the end it will cost a lot. And of course, what formats they should use. So we need to rethink the role of the archives in the digital age, because the records are not as simple as they used to be, just records on a sheet of paper or in a book. They are coming in the form of complex digital systems, and to reuse them, we need to know how to restructure those systems, reuse them for the future, and so on. So we see that we have two main categories that we need to address in this field. The first is, how are we going to archive the existing systems? We need to do some manual labor here that cannot be done otherwise. This is where we are proposing that the archives work together with the data producers in order to save as much data as possible and to find a way how to store it and preserve it in the long-term fashion. But the second, the most important thing is how to preserve systems and data in a proactive fashion by designing new systems in a way that automate preservation of data and that create a workflow where geodata or any other records are preserved automatically. This is something that we are going to address in our guidelines, and by showing you the next workflow, I think we will have more information about it. So proactive preservation in the new and existing systems should address the geodata lifecycle. We recommend that we put a special step of preservation activities in between the data creation in the production systems and the distribution systems. So before we publish the data, to make it public and official, we should create an archival copy that can be later used to define what was the exact state of the records at a certain time in the past, and this would solve the use case we had before about the building permits. So the approaches we should use in the preservation activities are conversion to a long-term preservation format, copy to a long-term medium like tape or disk storage, secure the storage, have multiple copies in different mediums, add metadata and documentation so that the data itself can be reused without the people who used it before. Because if you only have some tables or some rasters or some vector data sets and you don't know the context in which they were used, they're useless. Then we should export all this data to a archival repository, maybe to the archives, or create a local archival repository within the organization who employs some people that have preservation knowledge, let's say knowledge from the preservation field. And of course, we should deploy the data to the proper archive every 5 years, or at least we should have a 5-year cycle to preserve our systems that are currently running. And the second approach is how to archive the existing systems. Well, first of all, the archivists and the data producers need to identify which data is archival, which data should be stored for the long term. However, in the view of the future data economy, this data would increase more than it usually did, because usually the archivists only took some samples to have a historical view of the types of data that people used. But now we want to use all the data in order to facilitate the applications in the AI. So what we should do is start with the base maps, because this is where all other records are being referenced to. For instance, we had an experience with the Ministry of Culture, and their records were actually based on the cadastral data sets and orthophoto images, and we would need to store those images from the Ministry of Culture if we didn't have the base maps for the Surveying and Mapping Agency. So this also saves us a lot of space by going after the right steps. So after we identified the base maps, we convert them to a long-term preservation format, we gather the documentation, and then package and archive it in a proper way. This means package and document with the metadata and archive it on different types of mediums so that we can preserve them for the long term. Now, this picture actually shows the OIS process within the archive, and I created this for all the people from the archives that are actually using the OIS process. So before we spoke about the pre-ingest process, how to work with the producers, which data to use. And now let me tell you what you need to do in the archives to actually apply geodata, digital geodata archiving. In the ingest step, you need to have tools and knowledge how to validate the geodata, how to reuse it in a similar way to create a temporary DIP. And then you need to think about tools that you will use to do the mass conversions when the data formats become obsolete in a couple of years. And the last step is to make it accessible through web service-oriented architecture, where we publish the geodata metadata and the archival metadata to a search engine that enables us to access the records through a web service application platform that can be installed either within the archives, or it can be installed or it can be hosted at the National Mapping Agency, for instance. So there are many ways to approach this step, and we need to start working together with the different stakeholders in this process. Because if you see, we're not talking about archives being the place where data goes to die. This is actually a recycling of geodata. So we need to be part of the data lifecycle process from the beginning to end, and then starting at the beginning again. So the archives will need to engage with the future of data collection, and data producers will need to engage with the ways to archive and recycle the data. The next strategy that comes to mind is that we usually have a data strategy for geodata, which is rather complex to manage and distribute and interpret. So basically, the archives used to do it in a way that the producer exported the data from their own original system, packaged it in a proper way, documented it, and transferred it to the archives, where the archive took care of it for the long term and dealt with all the preservation issues. But in this case, we see that the archivists usually lack the geospatial expertise, and can be difficult to get. It can be difficult to get a geospatial expert to work in the archive only with the geodata, at least at the beginning. So we recommend that the archives connect with the producers that have more expertise with national mapping agencies, maybe, and discuss if this is the best approach. So we see that the original system is transformed, so the data from the original system is transferred to the archive, or the second approach where we advise, so the archive connects to the producer and advises them on the preservation strategies so that they can create a preservation environment within their own system. But they need to know that creating an archival environment also comes with a lot of cost, because they need to have 3 locations and different types of mediums and so on. But it is a different option if the producer needs to access the archival records very often. This is something that is very useful because sometimes the producers maintain the data on site because they need them, but they lack the preservation knowledge. And we had the example, as I mentioned before, that the mapping agency scanned 72,000 maps in TIFF format. They put the scans on tapes. Then because the TIFF format was too big, they converted it to a smaller compressed format, which is now being widely used, but it is not an archival format because it is a lossy compression and we lose the information. However, the tapes were left on the tape unattended for 15 years, and now if we want to access the TIFF files that have been scanned at the time, we have a difficulty because most of it is unreadable, but if it is, it also has errors in the files and so on. So a lot of information was lost, a lot of effort was lost, and this is why the archives and the producers need to connect in the digital age and educate each other on the types of data they have and how to preserve it. Now this slide is intended for those in the archives who are asking themselves, but who actually owns geodata aside from the mapping agency and the environmental agency? As we saw before in the beginning, we said that almost 80% of the information is related to space and to location. So I'm giving you some ideas of what type of organizations in your country actually uses geodata. Besides the most obvious public offices, public ministries or agencies like environmental agency, agriculture, transportation ministry, police, defense, municipalities that use geospatial data for spatial planning, tourist maps, disaster response, and of course a very recent case of epidemiology. We use a lot of maps to see how the disease is spreading and so on. You also have a lot of organizations that are private or that are state-owned that use maps like electricity, petrol, gas, water, sewage, telecom, logistics, waste management. So everyone who has their infrastructure located in space needs some type of geodata to manage it, to address issues of repair, to plan the future expansions and so on. And also we have institutes that research data and manage the forests, fishing, geology, water, economics, and health. So this concludes my presentation of strategies, and I hope you got a lot of information, a lot of useful information. And to tell you that we are here to help you. So help us help you, please. I would like to invite you again to review the Geo CITS documentation and tell us, is there anything you need us to clarify? Are we covering all your needs? Did we forget something? Do you have any suggestions? Then what type of training and consulting you need? What online training would help you most? And what topics on geodata preservation interest you most in the field of training and consulting? And of course, what would you expect from the implementation guides? What are your questions? After you read the CITS documentation, tell us where do you think you might have challenges of implementing these geospatial data preservation specifications.